Okay, I hope.
Hello, good morning, Pranay sir. How are you?
Good morning, Dr. Varnika. We have Dr. Zubeda as well.
Yeah. Dr. Pivnika, good morning.
Morning, Zubeda ma'am.
So we have two experts in this session, Dr. Varnika Agarwal and Dr. Zubeda ma'am. So it will be fruitful for the participants to have your views on their topics, and I hope they will be able to foster their research in a publication form. So we are just in
Sir,
generally. Yes, ma'am.
have you sent that the form for the marks?
I am sharing it on the on WhatsApp. Yes, thank you. I'll be sharing the link with you. That is the evaluation link where you can give the marks to the participants or the evaluation sheet. Just wait. I am doing that. I have shared the link, ma'am. Please check whether it is working properly or not. Just let me know if you are not able to edit it. Then we will be.
I will.
Vanessa, I think I am not able to edit it, so the experts might not be able to edit the sheet.
So, sir, what is your area of expertise?
Ma'am, actually, I am a finance faculty, so I usually work on time series information. So I use econometric models like Arch and Gauch models and panel regressions like VECM models and WARE models. Although I do not have that much of research papers the way you or both the session experts have.
Like that.
But I have a keen interest on the secondary data rather than the primary one. I have never done the primary analysis where the use of a MOS software or the other softwares are being used.
So we are more into MCDM. I am particularly more into MCDM.
So, आपकी voice break कर रही है.
those.
Your voice is breaking a bit. Just check.
Let me connect. Let me check. Yeah.
Yes, please do check.
I hope sound is better.
Okay, fine. Yes. Yes, ma'am. Please tell what is your area of research you are talking about that.
I work predominantly in the area of multi-criteria decision making and modeling.
Okay, great. Fine.
I think I'm not able to see Zubeda ma'am.
Zubeda ma'am, camera is off from your end. It will be better if you can turn on your camera.
Not now, not possible now. So I'm in my way to my work. So I will be driving in a few minutes. So once I will be in my office, I will open it.
Okay, not an issue. Not
Sorry.
an issue. Okay, fine. So before starting the session, we are left with only 2 minutes. So let me brief about the session. In total, we have total number of participants is 14 in this session, and we will be giving every participant 10 minutes, 7 minutes for the presentation, and then 3 minutes for the discussion where the experts or even the other participants can ask their queries, or if they want any clarification for the same, then definitely they can go for that. And although this time frame is not very fixed, it can be extended to 15 minutes also, depending upon the type of research it is. And as far as the evaluation pattern is concerned, it is having five major parameters. The parameter one is relevance of the study, then parameter two is quality, then parameter three is technical inclination, fourth parameter is how the participant has presented, and the last parameter is the novelty. So these are the parameters on which the presenters will be judged, and the evaluation is being done by the session experts. Pranay sir, we are still not able to edit it. So I don't know because, or let me refresh my spreadsheet.
No, I'm able to edit it.
Okay, so I might not have refreshed. Just yes, yes. Fine, fine, fine. Yes, now it is fine. Because I opened the sheet at 10 a.m. and I have not refreshed it. Fine. So we are going to start uh, this one. Room number 211. Okay. So so we should start it now. So let me welcome all the participants along with the session experts. We are delighted to welcome you all to International Conference on Emerging Trends in Engineering, Technology and Management 2025, organized by MIT International Business School, MIT University, Noida, India. This conference brings together researchers, academicians, and industry experts to share their insights. And we have this conference in collaboration with IEEE. IEEE is the world's largest technical professional organization dedicated to advancing technology for benefit of humanity. IEEE and its members inspire a global community through its highly cited publications, conferences, technology standards, and professionals and education activities. So IEEE has more than 4 lakh members in 190 countries. And as far as the students are concerned, we are having a number more than 1 lakh 50,000 students members. And there are around 2,700 chapters and 3,500 student branches and 4,100 student branches chapters in IEEE technical societies. MIT University, in collaboration with IEEE, has come with international conference on this topic. The objective of this conference is to address the most essential issues of engineering, technology, computation, automation, and knowledge management. It also serves to foster communication among researchers and practitioners working in wide variety of scientific areas with a common interest in improvement of on these fields. So without wasting any time, so let me introduce my session experts for these 3 hours, that is from 11 to 2. I hope it will be engaging one. So my first session expert is Dr. Zubeda. She is assistant professor of industrial engineering in Liva University. She has a diverse academic and professional background, including expertise in lean work design, carbon emission optimization, and circular economy strategies. Dr. Zubeda has authored and co-authored multiple papers in high-impact journals focusing on sustainable operations, digitization, and innovation practices in engineering and management. She is actively involved in mentoring students and leading research projects, including her current work on quantitative assessments of the economic impact and technological integration of sustainable materials in construction projects. Additionally, Dr. Zubaida serves as the guest editor of the special issue in Scopus Q2 journal, that is Environment and Behavior, and is dedicated academic counselor and coach. Her contribution to academia are remarked by a commitment to sustainable innovation and fostering student success. So welcome, Dr. Zubeda. And now my second expert is Dr. Varnika Agarwal. She is Associate Professor in Operations at APJ School of Management, Dwarka, New Delhi, India. Her expertise span diverse domains including green supply chain, circular economy, sustainability, cross disciplinary research in supply chain and operations management, optimization, reverse logistics, and empirical research. So many topics she is comfortable with doing research. That is amazing to have you, ma'am. Having earned her doctorate in operations and supply chain management from Department of Operational Research at University of Delhi in the year 2019. She has an impressive record of many research papers featured in esteemed national and international journals as well as presented at various conferences. Her scholarly impact is underscored by her research publication in business strategy and the environment, a significant presence in ABDC listed journals. Notably, she serves as the guest editor for the special issue on MSMEs, resilience and performance, COVID-19 perspective in benchmarking Emerald ABDCB journal. Adding to her accomplishment, she has authored a book titled Lean and Green Manufacturing Towards Eco-Efficiency and Business Performance, featured in Management and Industrial Engineering book series by Springer. Currently, she has 50 Scopus Index publications. So both of our experts are renowned researchers in their specific areas. We all are happy to be with us for this session. So shall we start by all means? Varnika ma'am, with due respect, along with Zubida ma'am, should we start?
Yes,
Oh,
yes, yes,
okay.
yes, please. Let's start the first.
Okay, then
Yes,
my
yeah, please
first.
let's start with the first paper.
Okay, ma'am, fine. So we are here having, let me see the names of Shripal Reddy. Is Shripal Reddy here? Paper ID is 213.
Yes.
Yes, sir. Thank you. I request you to share your screen and you can start your presentation.
Is my screen visible?
Yes, sir. Please go ahead. All the best.
Yeah, thank you. Good morning, everyone. My name is Shripal Reddy Bolla, and I am excited to welcome you to this presentation on reinforcement learning applied to AI chatbots. As technology rapidly transforms, there is an increasing expectation for digital assistants to offer not just automation but intelligence. So in this session, we will walk through the design, implementation, and the results of building a self-improving chatbot using reinforcement learning and explore how it sets a new benchmark for adaptive virtual assistant. So coming to agenda, before we dive in, here is a quick overview of what I will be covering. So we'll start with the title and introduction to set the stage, then walk through the key gaps in existing chatbot systems and the objectives behind our research. After that, I will explain our methodology, followed by analysis and key findings, including how our model improved over time. We will then look at the broader implications, like some real world use cases and the underlying architecture. So I will also briefly touch on the ethical consideration, and finally we'll wrap up with Q&A session. So coming to introduction, like most of us have used chatbots for support, banking, or travel, but they often feel robotic. They follow fixed rules, give generic replies, and don't improve over time. So this lack of personalization and adaptability can be frustrating. Every interaction feels like starting from scratch. So reinforcement learning changes that. It allows chatbots to learn from experience, adapting to user behavior, adjusting tone, and getting better over time. That's the core of our work, creating chatbots that evolve, understand the context, and deliver more human-like, helpful conversation. Let's now explain the specific gaps we set out to address. So traditional chatbots have three big limitations. First, they don't improve after deployment. There is no learning from user interactions. Second one is they lack emotional awareness. They don't pick up on like frustration or confusion and can't adjust their tone accordingly. And third one is they are not personalized, like they don't remember preferences or past conversations. So every interactions feels the same. So these were the key gaps we aimed to address by building a chatbot that could learn continuously, understand emotion, and personalize the experience. Let me show you what our research set out to achieve and how we approached the solution. So coming to objectives of this research, like our goal was move beyond basic chatbot replace and create one that learns, adapts, and gets better with each interaction. So we wanted it to understand user behavior, remember past conversations, and even respond with empathy. So to achieve that, we used two-phase approach. First, supervised learning to teach the basics of conversation, then reinforcement learning to help it improve. Like am I sharing my PPT?
Yes, sir, PPT is visible.
Oh, sorry.
And now it is not.
Okay,
Not
okay.
visible now.
Sorry. Yeah, yeah, sorry, like I got confused actually. Okay.
It is visible now, sir.
Yeah, sure. So, okay, let's now take a closer look at how we built and trained the system in the methodology. So, coming to methodology, we built the chatbot in two key phases. First, we used supervised learning to teach it how conversations typically work using real dialogue data to build a solid foundation. Then we applied reinforcement learning where the chatbot started learning from interactions, improving based on feedback or rewards for helpful responses. So we tested these two RL algorithms like DQN and PPO, and I will share more on their differences shortly. So to ensure safety, we added human in the loop training where reviewers stepped in to guide the chatbot and prevent bad behavior. So and finally, we used memory networks so the chatbot could remember user preferences and past conversations, making the experience more personal and context aware. So let's coming to the analysis part. So after training, we tested the chatbot and the results were very encouraging. Like task success rate jumped from 65% to 87%, showing it was much better at helping users reach their goal. Conversation length also increased from 4 to 7 turns, like which means user stayed engaged longer. and the return user rate more than doubled, going from 28% to 61%. That's a strong sign of user satisfaction. And finally, empathic accuracy. So how well the chatbot responded with emotional awareness consistently stayed above 80%. So overall, reinforcement learning made the chatbot not just smarter but more engaging, human like. So let me tell some key findings. Like, we tested two reinforcement learning models, like DQN and PPO. So DQN is deep Q network, PPO is proximal policy optimization. So these stacked up against each other. Okay. Now coming to sorry yeah so in like PPO clearly outperformed when compared to DQN across the board. So it trained faster, produced more coherent responses, and had a lower error rate, under 2% compared to DQN's 4.7%. So PPO also delivered smoother, more natural conversations, which made interactions feel more human. So while both were effective, PPO gave us the best mix of speed, accuracy, and user experience. So let's now shift from the technical side and look at what these results mean in the real world. So coming to implications, uh, these improvements are these improvements are not just technical wins; they point to a biggest shift. So we are moving towards chatbots that are emotionally intelligent and truly adaptive. So systems that understand users, grow with them, and respond in more human-like ways. So in healthcare, this could mean a bot that checks in on patients with empathy. In education, a tutor that adjusts based on how a student is doing. In customer service, a bot that remembers you and resolve issues faster. So the real takeaway is this, like conversations with machines don't have to feel robotic anymore. So they can feel natural, helpful, even personal. Next, I will share a few real world examples of how this can be applied. So here is how this kind of chatbot can make a real impact. Like in healthcare, it can act like a virtual coach, checking in with patients, recognize emotional signals, and offering support that feels personal. In education, it becomes a smart tutor, adapting to how each student learns, offering encouragement and adjusting pace as needed. And in e-commerce, it serves as a helpful assistant, remembering past purchases and giving personalized, timely recommendation. In all these areas, the chatbot is not just answering questions; it's delivering value by learning and adapting. Now, let's take a look behind the scenes to understand how this system actually works. So here is a quick look at how the chatbot works behind the scenes. First, it processes the user's message, figuring out both the intent and the emotion behind it. Then the system looks at the full context, past chats, preferences, even time of the day, to build what we call the dialogue state. So the policy network then decides on the best response, like based on everything it has learned. So after the response, feedback from user behavior or human reviewers help the system improve. And finally, a memory layer stores useful details to make future conversations feel more personalized and consistent. So this loop, like sense, decide, respond, learn, is what keeps the chatbot evolving. Now, with all this intelligence comes responsibility. So let's talk about ethical side. So before wrapping up, I want to touch on something essential, like ethics. So when a chatbot learns from user, and stores preferences. We are dealing with sensitive things like data, trust. So we focused on three areas like bias and fairness, to prevent the system from making unfair decisions based on flawed training data. And another one is explainability, so users understand why the bot responds a certain way. And another one is like privacy and consent, so ensuring the bot only remembers what users agree to share and gives them full control. So for us, building a smart chatbot is also meant building a responsible one. So let's now head to the final slide. This brings us to the end. Thank you for your time and attention. And I look forward to the discussion. Yeah, thank you.
Questions
Yes,
from the
so
experts?
was this the chatbot that you have building, or it was some pre-existing model that you have done?
So this one is like when we visit any retail website, like we'll get assistant kind of chatbot. I'm talking about that one, like instead of fixed questionnaire, so we train the model and answer it accordingly, like a human like feel.
What was your sample size? What was the test case? How many users did you use for test, and how many will you use for validation?
Yeah, yeah. Actually, we used Google Cloud Platform, as I have been working on that particular area. So we used BigQuery and Vertex AI. Especially in Vertex AI, we used some training containers. So coming to a data set, we used, I can say, like a couple of thousands as a sample. Like we even tested with a small set of people, and before and after the implementation.
So the validity and the reliability, how are you placed on that for this?
Yeah, so we cross-checked like before and after implementation. So we cross-checked the answer, like as I mentioned in one slide, like so accuracy percentage got increased, and the conversation got increased from 3 steps to 7 steps, like that. And customers visited more than one time for the help, like as
So
and when.
how is it? My last question is, how is it different from what is already available in the market? So what?
So yeah, yeah, I got now. This been evaluated a lot. When we started this, like we observed some websites are having only standard template of questions, so they can't go beyond that. So in that particular area, so we took that sample and trained the data and improved the conversation, like a robot to human like conversation.
Thank you. That's all from my side.
Yeah, yeah, thank you very much, Varnika.
Okay. Thank you, sir. Dr. Zubeda ma'am, do you have any questions for uh, Sripal sir? Okay, thank you, Sripal sir. So we are going for the next.
Yeah, thank you very
Ma'am,
much.
yes, Zubeda ma'am, do you have any question?
Yes.
Nice to see you.
Thank you. I'm just no, I don't have any question. Thank you so much. I'm just
Okay, thank you, ma'am. Thank you.
Right, thank you.
So,
Thank
thank you, sir. So now, next participant, Piyush Kumar, paper ID 352. Piyush Kumar, paper ID 352.
Yeah, hello. Good morning, sir. Please
Yes,
to
good
say.
morning. Please share your screen and turn on your camera.
Just a second, sir.
Shripal sir, you can just stop sharing your screen so that Piyush can share the screen.
Sir, I have requested you to share my screen. Please allow me, sir.
Just try, sir. Are you able to share the screen now?
Just a second. Oh, yes, sir.
Yes, please. Please go ahead.
Sir, is it visible?
Yes, yes, yes.
Yeah. Good morning, one and all present here. This is Piyush Kumar, research scholar from Manasali Vidyapeeth, Rajasthan, India. My topic is minimizing the operational footprints of talent acquisition in Indian IT sector and AI-driven approach for sustainable growth. This presentation explores how the artificial intelligence is transforming the talent acquisition process in Indian IT sector, different organization under the Indian IT sector. And this will explore how the AI is improvising the organizational productivity as well, while keeping a focus on your talent acquisition. AI influence on recruitment process and organizational productivity. AI influences the recruitment process very smoothly, and it helps the recruiters to get the pool of applications at a single point of time from the vast area of the applications. It uses the different applications to screening for initial recruitment, initial interviews, primary interviews. It helps the recruiters for getting multiple options for a single vacant position. Organizational productivity, the AI influence organizational productivity in a positive manner. It to enhance the organizational productivity in terms of the recruitment and your talent acquisition. It provides the pool of candidates for better performance, better credibility. It performs the different tests, different initial processes under the recruitment process. AI application and theoretical perspective in talent acquisition. AI in recruitment. Chatbot automates the inquiries, interviews, and resume reviews, reducing cost, bias, and while enhancing recruiter focus on strategy. Digital recruitment expands the applicants pool but doesn't guarantee quality. It makes hard to quickly identify the top talent among the numerous applications. A versatile and cost-effective talent acquisition strategy is crucial, prioritizing culture fit over just skills. The recruitment process involves four key stages: sourcing potential candidate, online screening, online application against criteria, selection through evaluation, considering personal job, person team, and in organization fit. Now, algorithmic management. Algorithms as data-fed computer formulas for decision making, widely used in HR for data processing, decision support, and performance monitoring. These algorithms automate the task from employee monitoring to enhance human decisions, offering varying degree of control. Addressing algorithm evolution requires empowering algorithm with human-centric skills. In talent acquisition, algorithmic management employs descriptive, predictive, and perspective algorithms for analysis, fit assessment, and automation. The human AI interaction spectrum range from full automation to complete human involvement, presenting opportunities and challenges for transparent and engaging hiring processes. Research methodology and data collection analysis. The inductive method was used to examine the potential or organizational and operational effects of AI on talent acquisition and talent management. We use naturalistic inquiry technique to get the insight from interpretation into interpretation. This expands upon previous study that explores the relation between human contact and AI-based transactions. We collected the questionnaire from 11 HR experts from different recruiter organizations in the IT sector and IT companies. We use the qualitative data sources, and for data analysis, we use grounded theory algorithm and thematic analysis. Limitation and contextual considerations. One of the limitation of the study is the sample size. As you know, in the previous slide, we have collected only the 11 HR experts data for the data analysis. So yet there are so many scope. There is so many scope for the sample size. And again, the geographical context, again, as we are limited in the numbers of sample. So the geographical context, maybe if we go for the wider data collection, then can also be changed. Conceptual framework, organizational and operational dimensions, speed and efficiency. AI enables scalability, reduce time, processing time, and redesign the work to automate repetitive tasks, improving recruitment speed. Quality and validity, accuracy in the candidate matching is critical. Current AI achieves about 95% matches, but needed improvement to avoid missed top talent. Reliability, the AI must comply with the ethical standards and integrate with the existing system to ensure unbiased, dependable, and hiring processes. Now, AI versus traditional recruitment process. Initial evolution, if we talk about, AI automates resume screening, extracting key data from the identified key data and identify the gaps efficiently. Screening, the chatbot conducts the initial interviews and administer tests, providing data-driven candidate insights, which contributes the lesser paperwork and lesser timing, like lesser time consuming. Selection. Human recruiter focus on relation aspect, interviews, and final decision complementary AI efficiency. AI, again, AI helps the interviewers to perform many kind of the data analytical tools to assess to rightly assess the candidate. Practical implications for AI integration and talent acquisition. Hybrid modes combine AI for repetitive tasks with human focus on interviews and feedback, wellness efficiency with and empathy. As we all know, that recruitment is a kind of process which we done on a repetitive mode. So the AI helps the individuals to perform all kind of repetitive tasks very efficiently and with the accuracy of analysis. Personalized engagement, implement intelligent chatbot that provide contextual feedback and maintain candidate communication. Again, personalized engagement enables the recruiters to get in touch with each and every recruitee or the candidates. Algorithmic literacy, train HR teams to monitor AI designs for fairness, explainability, and bias mitigation. Again, the entire process is automated, but yet we require manpower to assess the process, to maintain, and to rightly assess, to rightly use the process. Governance framework ensures AI use aligned with ethical standards and diversity goals to build trust in recruitment.
Thank you, Piyush.
Discussion balancing. Yes, sir.
Are you left
Yes,
with
sir.
something or you are done?
Just one more slides. Conclusion.
Okay, fine,
Yeah,
please.
conclusion for future action. At the conclusion of the study, we have identified the still. Sorry. Just a second, sir. Yes. This study highlights the need for a balanced, ambitious approach, AI and talent acquisition, blending operational efficiency with relational engagement. So ultimately, the study finds we require AI processes for the technical purposes like data calculation, data interpretation, and the rest of the working. But still, we require manpower to assess those processes, to coordinate, to maintain those processes, and to regularly go with the flow, with the flow of them. And the future researchers should explore the AI application across diverse geographical and cultural, ensuring ethical, people-centric recruitment practices that support sustainable growth in Indian IT and beyond. So there is a future scope as well. Thank you so much, sir.
This
Hello?
session is open for Q and question and answer.
Yes.
Zubeda ma'am, do you have any question for this? Vanika ma'am?
Yeah.
Any question?
Okay. So this is the sample size. Don't you think 11 is a very small sample size for the paper?
Yes, but this could be, that's why this is the limitation of the study, which I have mentioned this.
So why did you stick for 11? Why not 12?
Ma'am, there was no specific reason for that. Actually, the responses were taking so much of time, and I was the limited in the time for the study. So that's why I go with the 11 size.
Normally, you don't do that. So when you are carrying out such kind of a thing, there is literature which
Yes, ma'am.
supports that when you should stop the survey. You should stop the survey either when the responses are repetitive in nature or no new information is being obtained. So even if you have a small sample size for thematic analysis, the sample size is not a problem. But where to stop? That criteria should be
Hello.
mentioned very clearly. Hello.
Yes, ma'am.
Uh, for thematic analysis, basically, when you stop, that should be clearly mentioned. So you cannot randomly stop that by convenient sampling. I am getting only 11 responses. You have
Okay.
to have some kind of scientific backing. So the literature says that you can either stop when you have repeated number of the answers are coming out to be repeated, or when no new information is being obtained. So you should find the paper which states that and you should cite that when your sample size is small.
Okay.
So that's
Thank you so much. Definitely, ma'am.
so Dr. Zaveda, if you have.
Okay, thank you, Piyush. Let's move to the next
Yeah,
participant.
thank you so much, sir.
Ayusha. Ayusha, paper ID 161. Yes. Please share your screen also, the presentation, and you can start. Yes, your screen is visible. Please start.
Hello everyone. Myself Ayush. So I have researched on a few machine learning models for predicting the earthquake magnitudes. So following up, we have the table of content, which we will discuss about the introduction, followed by literature review. Then we will look into the research gaps and objective, along with the methodology and the key findings. We'll end the presentation with the performance matrices, implications, and the conclusion. So let's start with understanding, just a second, understanding the challenges. Earthquake, as we all know, earthquake is a major disaster happening everywhere in the world. So in the few past times, we have seen Nepal and other countries facing a huge amount of destruction due to earthquake. So earthquake have devastating consequences, causing significant loss in both economical and as well as the human way. So using machine learning, which offers a solution to enable study this complex seismic data to predict the magnitudes of the earthquake in various following areas. So why we are using machine learning, because the simple conventional statistic techniques cannot cope up with the overwhelming amount of multivariate data. For example, there are multiple things which we have to look into before predicting the magnitude, such as the depth, such as the seismic uh, graph patterns. So using statistical techniques, we cannot actually give correct prediction. So ML models come into the game and it handle large and heterogeneous data set. Also have an edge over the traditional methods. So following up, we have the literature review. I have like studies few research paper before making my own, and the few findings which I have found is many of them have used models such as random forest, ANN, KNN, and SVM. So regarding all of these, one common thing was there. Everyone have used the random forest, which is the most common models among uh, predicting the earthquake magnitude as well as in climatic conditions, for predicting climatic conditions also. So moving forward, we have the research gaps. So most study evaluates the ML models like, as I mentioned, RF, ANN, and KNN in isolation, but not in a controlled comparative setup. Everyone has used it in a single way. Like they have only used the random forest, either they have used the ANN, but in this we have comparing three of them together and finding out which one of them is more suitable for predicting the magnitudes. Existing model often ignores the temporal aspect as well as the spatial features superficially, but here we have like uh, looking into both the temporal as well as the spatial features of the data. So some of the models have also given also shows that it has some degradation in the prediction of predicting the magnitude at high accuracy, which is very critical and underexplored. So we will also seeing how these models can help in predicting the earthquake in having large magnitudes. So the research objective is comparing of three different models: random forest, artificial neural network, and k-nearest neighbors, which is KNN. And we're gonna evaluate their capabilities in predicting the earthquake magnitudes. So methodology overview. Random forest helps us to, like, it basically creates multiple decision trees and combining the inputs for improved prediction accuracy. Following up, we have KNN, a simple and powerful algorithm which makes prediction by comparing the data points. And at last, we have the ANN. It has linear and non-linear techniques to predict the outcome based on the environmental variables. And for evaluation matrices, I have used the mean absolute error, that is ME, and data I have collected in from Kaggle, which is a very known site for getting the data. And in the resultant findings, so what I have personally find out is the random forest, which was also common among other papers, other references, and in my also I have found that it has the best performance with 0.323291 ME score, which is the lowest among all of the three models. And it also handles non-linear relationship and large data set very well. It also comes with weaknesses like accuracy dropped in with insufficient data, training data. We need some sufficient training data to get that accuracy, proper accuracy we want. Followed by ANN, as we can see, it's 0.3660. And it also have some strength, like it is excellent for high resolution and regional data, and it has very high computational requirements and poor global stability. So we need some better machines to actually use ANN properly. Uh, just a second. And regarding the KNN, we got the score of 0.3758, suitable for simple data set, but it don't have that kind of stability like the other models. So here is the performance matrices. As we can see in the predicted versus actual values, random forest have some better performance. It is like situated very close to the standard line, which we have drawn here. So the dots are really scattered nearly to the median line, which we have used. And also for the residual part is basically the predicted value minus the actual value. And we can see here also random forest has been doing exceptionally well in both predicting the magnitudes. So this is the overall graph. We can see the random forest having, as I've explained before, 0.3291, which is shown here in as a graph, and which is the lowest among all the three. So if we talk about the implication, uh, random forest also predicts the accuracy and can enhance the seismic early warning system, which provides more reliable and you can say which provides faster and more reliable magnitude estimates without any error. And it also helps the governments to resource allocation for the disaster management. If we can predict the earthquake magnitudes before it will occur, so we can allocate that kind of we can allocate that kind of resources to minimize the damage. And for the guidance of the model selection, researchers and engineers can rely on random forest as the first choice of model, which reduce the time experimenting less scalable or tunable options. So in conclusion, we have seen that random forest emerged as the most robust as well as the accurate model for earthquake prediction. ANN performs well, but required extensive tuning and high computational power, as I explained before. And if we talk about KNN, it is the baseline accuracy. It's like the base model you can use, but it's struggling with the large number of data set or non-linear data set. So for future research, one should explore making a hybrid model to enhance the predictive accuracy. Thank you so much. Now we can. I would like to invite the questions regarding the.
Obviously, very interesting study, and actually, it is good to know that you have actually picked up real life data and worked on that. So, because your model is showing significant validation across this data, have you tested it on some other data from Kaggle?
Ma'am, voice isn't clear.
Yeah. Have you tested it for some other data also?
Ma'am, I have tested it for before coming to the earthquake. I have tested it for the climatic disaster for such like cyclones, tsunamis, and etc. But in there, there are few research we have that have already done it before. So I thought it would be beneficial. I should go for earthquake magnitudes because it's research are there, but there is not comparative study between these three models. So I have choose this earthquake magnitude. I have research on other aspect as well as I explained.
Yeah. So I think good work for humanitarian aspect of it. I think it is a good publication option that maybe you can carry forward.
Any other question, or should we move ahead with the next participant?
Yes, please. So one question about the data. Is there any challenge? Did you get any challenge to get the data for this study?
Yeah, during while researching about the data, I was facing some issues like there was no particular attributes on which I could predict the data, as well as many of the data are all about longitude, latitude, and depth. There is no as such mention of magnitudes in various data which I have explored. So regarding this, magnitude is what we need for actually predicting the values for the for for the models. And I have also researched many of the data, and they have might miss on the timings or they have might miss on the magnitudes. So these are the some challenges I have faced while getting on this data.
That's all. Thank you.
Thank you so much.
Okay, thank you, Ayush. We're moving ahead with paper ID 268. Nitin Magar.
Yes, sir. Hello.
Okay, yes, you are audible, sir. Please turn on your camera and then you can share your presentation with us. Nitin, sir, we are not able to see you properly, reason being that because of the light behind you. It would have been better if you can sit opposite,
Okay, sir.
if possible, so that we can also see you.
Yes, sir. 1 minute. Just
Happy faces.
okay, sir. Net connection in the.
Okay, fine. Please go ahead. Share your screen first.
Yes, sir.
Yes, we are able to see. Please move ahead. All the best.
Okay, sir. Thank you. Can you see my screen, sir? Properly?
Yes, sir. Yes, sir. Nitin, sir, please move ahead. Please present.
Good morning, all of you. Myself, Nitin Sonaji Magar. My paper topic survey of the heart disease prediction model using the machine learning and deep learning techniques. Uh, First, we go through the first slide, introduction.
If you can put it on the slideshow mode, please.
Okay, ma'am.
Thank you.
First, go through the introduction. In that, heart disease is a globally leading causes of the death. WHO, World Health Organization, 2.5 million death due to CVD. This number of is expected to reach 24.2 millions by the year of about the 2030. Each year, USA it takes the lives of about the 40,000 people. The cardiovascular disease is one of the most diagnosis and potentially fatal chronic disorder that may be seen all over the globe. Construction of the coronary arteries and blockage of the coronary arteries are the two primary causes of the heart failure syndrome. Early diagnosis is essential. In this slide, provide the alarming the statistics of the underscore of the global health burden of the heart disease. It highlights why the research is necessary. The rising trend, the cardiovascular is related to date of emphasis needed by the better diagnostic tools. Then next, review about the this topic. Cardiovascular disease, in fact, CVD is a leading causes of the death globally, with heart attack and strokes account for the over 80% of related fatalities. Diagnostic challenges, traditionally tools like ECG and angiographics having the limitations of the either lacking precision of the being the invasive and costly. Machine learning advantages. Machine learning techniques offer the accurate, non-invasive and cost-effective alternative for the early detection of the heart disease. Commonly used algorithm study the frequently apply SVM neural network in assemble models and decision tree are the prediction of decision classifications. In this slide, problem linking the problem of with the solution. Traditionally, diagnostic techniques are the obtain the invasive and expensive of the sometimes not very accurate techniques and machine learning where the allow the predictive modeling based on pattern in the clinical data. Next, some top papers are review, and that papers we find some findings. Then machine learning and deep learning technique for the heart disease predictions. ML algorithms like decision tree, SVM, random forest, and XGBoots effectively predict the CVD using the structural clinical data, offering the high interpolated supervised and unsupervised learning. Supervised use the label data predictions. Unsupervised identify the hidden patterns and use the clustering. Both critical heart disease analysis. Deep learning techniques such as ANN, CNN, and RNN excel at handling the complex data to ECG signal time series and medical images, making the human configuring process. CNN are the best for the detecting visual pattern for the medical images, and RNN RNN excel at the processing sequentially data like pattern monitoring over the time. Hybrid and explainable AI models combining these ML-DL approaches for the improve the accuracy and transparency in clinical decision making. Then research gap, lack of the interpretability in the DL models, limited real-time deployment, need for need for the multi-mode model data integration, accuracy focus over the clinical relevance. Then some objectives, evaluate the machine learning and deep learning techniques for CVD predictions, compare the traditional and hybrid models, purpose of CNN and LSTM for the higher accuracy, identify the significant predictive features. Then methodologies, systematic overflow, the study that involve the stages, data collections, pre-processing, feature selection, model training, evaluation, and comparison of the identify the optimal predictive models. The first is the data and pre-processing using the clinical record, medical images, and ECG signals. Apply the normalization on what encoding outlier removal and smoothie for the class balance. Model implementation, machine learning model like SVMX, Boost, and DL model, NN, CNN, RNN, like this. Develop the using the for with hyperparameter turning, performance evaluations. Compare the using accuracy, precision, recall, F1 scores, and cross validations to the ensure the rebootsness and generalization. Finding the feature work, hybrid CNN, LSTM show the top performance feature detection, including real-time deployment and fitted learning, and improve the model explanation abilities. This is for the quality of evidence of how will be each model perform the expert output outperform the other the both accuracy and AUC. Decision tree overfit the data, which is the common problem when trees are not full. Then finding the future work, hybrid CNN, LSTM show top performance future direction, including the real-time deployment, federated learning, and improve the model explain abilities. This is the model. First, collect the data sets, train the data, the pre-processing and normalization, feature generation, feature selection, and analyze the feature selection. After feature selection analysis, and then finally is the result. Analysis, ML models, X boots 92 point accuracy and 91.3 AUC, random forest 88.6 accuracy, then decision tree is a 7.5 accuracy or fitting. Then DL models, deep learning models, CNN plus LSTM, that is a 95.6 accuracy and 96.8 AUC, and LSTM, that is a long short term memory, 94.1 accuracy, time series 10, RNN 88.5 accuracies. Then findings, hybrid models outperform the traditional ones. Top features, Polestar, Edge, and BP, and balanced data set enhanced accuracies. Implications, all support early diagnosis, hybrid models suitable for the clinical users, need for explainable AI, federated learning, wearable touch integration potentials. And finally, that is a conclusion. Machine learning and deep learning significantly improve the predictions, CNN is the LSTM achieved the best performance. CNN plus LSTM is achieved the best performance, and future was interpretive of real-time deployment. So some references. Finally, thank you.
Okay, I think the good work done over here. So how much data did you test it for this?
Hello, ma'am.
How much data did you test for this? What is the size of the data?
Size of the data is available on UCI. UCI data set is available.
Okay.
Yes.
Okay. So did you do some testing and then validation, or only one phase of the data?
Ma'am, not a testing, only one phase of the data.
But so how can you verify the validity then?
Yes, ma'am.
So how did you make sure it was valid? The model was valid.
Okay.
What? So I think maybe you could work on the reliability and validation of the data set.
Yes, ma'am. Hello.
Maybe you can work on the validity part of the data.
Hello.
Okay, thank you.
Okay, ma'am. Thank you.
Okay, so thank you, Nitin. Let's move to paper ID 270. Virendra. Virendra.
Sir, hello.
Yes.
Virendra is joining another track. Hello.
Yes, Virendra, are you here?
Yes.
So please turn on your camera and share your screen so that we can see your presentation.
Once.
Is there any network issue at your end, Virendra? Okay, fine. Yes, we are able to see you, sir.
Okay.
Can we see your presentation also?
Yes, yes. 1 second.
Yes, it is.
Are you
It is
able to see
visible
my
to
slide?
us. Visible to us. Yes. Please start. Thank you. All this.
Yes. Okay, thank you. Thank you. So first of all, I would like to thanks Amity University and the IEEE Long Bench section to give me an opportunity to present this paper. My topic is the comprehensive study for the accuracy in 3D mapping creation using sensor fusion techniques in SLAM. I'm the student of Pune University for the PhD, and my guide is Anaga Kulkarni from Pune University. So the content of my paper would be as you can see. First is the introduction. Second, the literature review, evaluation matrix, experimental validation, results discussion, and future directions. So as we want to study the comparative analysis for the sensor fusion in SLAM, we should to create a 3D mapping. We should know why 3D mapping is more important to us. So it gives an accurate precision into the using the environmental understanding that using the environmental understanding, like the case studies like the surgical navigation, where we can create a 3D mapping and the doctors could do an operations with an accuracy of 0.1 millimeters, and it reduces complication of any surgical operations. Even also in the construction side, we can design the 3D mapping, which helps us to reduce the rework, or whether we are going into whether we are creating unnecessary changes or going for the structure of the system or the bridge or something like that, or the building, is it correct or not? We can use it with the 3D mapping creations from the SLAM also. So here the role actually plays a very important role, the sensor fusion role, where the mixture of multiple sensors could help us to get the approximity, and the error could be less than the 0.5%. So how this could be there. So before to that, I would like to just highlight with the literature review. Here I have studied from the different research papers that the ladder is used for the geometric construction, as what I have explained you earlier, where the accuracy of 2 centimeter is there, with the 250-meter range. But if suppose any reflection surface is occurred for the ladder, at that time the error could get and the accuracy won't be there much, and there would be a 50% of errors. So the same way, like in RGB cameras also, due to the dynamic lighting, we can say that the features which needs to be extracted with the camera could go down to the 40%. Also, the another sensor like internal measurement units, this could have a angular drift of 0.55%. So during this analysis, I've gone through some fusion techniques also, and it has been observed that if there is a ladder and the internal odometer, the combination of these two sensors, then the drift moves towards the 38%. So it reduces from the normal of 40 to 38% using these Kalman methods techniques. And also some dynamic priority sensors, like suppose there is a low light is there, we can have the thermal camera and the LiDAR combination, and this gives you the more or it able to detect the obstacles among it. So mainly, what are the factors which the 3D mappings occurred? What I have studied is that first of all, the environmental conditions. In the environmental conditions, the lighting variations could be there. If there is a smoky or the thunderstorm is there, or in the night, some devices would work and some not. Also there could be a issue of the surface reflexivity of the if suppose the camera is trying to capture any image and suddenly some half of the part is reflecting something, then the camera would identify that object into a different prospect. So that could be one more the factor for it. Also from the hardware limitation side, the sensor synchronization and calibrate drift is the main concern from the accuracy point of view. And there are some algorithm constraint also we will see in the next slides. So usually how to evaluate this and how to measure that the accuracy for it. So there are basically the two evaluation metrics. One is the absolute trajectory error, and the another is the relative pose error. In absolute trajectory error, the LiDAR remains the same thing. Yeah. It just calculates. 1 second. Sorry. Yeah. It just calculate the differences among the LiDAR or RGB cameras, and then give us the trajectory, how much difference is coming onto it. Moving to the next slide, in the experimental side, I have seen some data sets like the TAQ SLAM and the HIT, where multiple different types of sensors are being used. The kinetic sensors are being used, and it has been observed that there are uh, some trajectory errors has been measured, and these are the more minimum trajectory errors. When have in the third row, if you see the Hilit 2022, the ladder and the IOMU combination is there, then the error is less as compared to that. Also, I saw some of the hardware test beds. Here, here we can see that uh, the um, Boston Dynamics Spot. This is one of the platform, and the payload capacity is of the median, we can say, and the speed is okay, but the accuracy of the SLAM has is been the good as compared to the different another platforms which are being run through the to check the sensor fusion techniques for the SLAM accuracy. And here are the some accuracy, some results I have just tried to identify and see how the accuracy and the robustness of each sensors are there, and along with the fusion sensor fusion. Like for the indoor, the LiDAR is showing as 2.1 centimeters, whereas the shows the accuracy of 12 centimeters. But when we have the combination of LiDAR IMU camera, we can see the accuracy of 0.8 centimeters, centimeters into it. Whereas during the feature extraction, we can see the 87 accuracy, 87% accuracy is using the multiple sensor fusions compared to the individual ones, and the angular drift for the SLAM who is using the multiple one is the least one. From the resource efficiency point of view, if you want to see, we can say that the uh, low cost of sensor types are being used in the sensor fusion, and the cost of the hardware could also be reduced to up to the 70% if multiple sensors we are using for the precision of the creation of the 3D maps. Uh, Even the processing time is being reduced when we are having the combinational sensors onto it. Um, apart from the resource efficiency and accuracy, if I compare with the environmental robustness, I can see that in the low light environment, the sensor fusion gives me 90% of completeness in the or in the map, whereas it is very useful for in the dynamic environment, uh, and any false information would be reduced to it. Even the calibration drift for the for this one is been less as compared to the single sensors. And in the foggy environment, we can say that the um, it is modulate or modulates the fusion composite modulate, and in the texture like surface, like extracting the features and all, the it is quite better and having a good depth estimation onto it. So from the feature direction, what are exactly the challenge areas uh, is that from the hardware limitations point of view. Um, for the LiDAR, we know that there is a high resolution needs to be there, and the power consumption needs to be more. So so from the power and the weight perspective for the drones, if you see your unmanned vehicles, there is a limitations to use such type of this sensors onto it. Also, there are many multiple challenges like payload data association needs efficiency or the application impact onto it. Thank you for this.
Thank you. No questions from my end.
Okay. Thank you. Zubeda ma'am, do you have any question for the participant, Virendra ji? Dr. Zubeda, any question?
Yes, please. Could you talk us a little bit about the limitation of this of the high? You talked about that LiDAR is shown to provide high accuracy. So what are the limitations when designing a fusion system?
Yeah, as I mentioned into the my last slide, like for unmanned vehicle, you can say that all this the power consumption of the LiDAR sensor or the weight of the LiDAR is too much. So so I want to just say in very short way that some sensors needs to be more compact or the designing of the sensors for the consumption of the electricity should be less. Even like you can also say that from the algorithm point of view also, some semantic filtration needs to be there, or the motion awareness of the slams needs to be there in from the feature perspective, because it is very the reason here is that it is very challenging one to distinguish between the static and the dynamic elements, the algorithm point of view. So that would be the one thing. Another thing, like autonomous drones or delivery robots in the smart city navigation system, that could be impact, and we need to have the reliability or the development of scalability for these particular limits.
Okay, thank you. Veronica, if you have any question.
Okay, thank you, Virendra ji. Thank you for the presentation. Let's move to the next participant. Paper ID 269, Prashant. Yes, sir. We can see you. Please share your screen and then you can present your paper.
Can you please confirm if the screen is visible?
Yes, we are able to see your screen. Please make it a full one so that we can see it clearly. Yes, please go ahead.
Thank you. Thank you, Amity, for giving me an opportunity to present the paper into this conference. Basically, myself, Prashant Baste, I'll be presenting my research on the analysis of deep learning models for the driver emotion detection. This is going to be outline for the today's presentation. I'll be starting with the introduction, then I'll be covering the objective methodologies, the model analysis, what are the findings, and finally the conclusion. So to start with this, the purpose of having this research is Nowadays, the number of vehicles on the road are increasing, and hence the overall traffic is getting increased. With the increase in the vehicles as well as the traffic, the safety concern are come into the pictures. So the one of the major impact or one of the major key criteria that plays a role into the road safety is emotional state of the driver. Why this is critical KPI? Because the driver performance is directly relational with the emotional state of the driver. So, for example, there are the some of the standard emotions. Those are categorized into we can categorize them into the positive impacting emotions and the negative impacting emotions. For example, if the driver is having a happy state, or he is a uh, neutral, or he is a calm, so basically the performance will be neutral, and there are less chances of accidents or the harsh driving, we can call it as. If he is a in happy state, or he is having a happy emotions, he'll drive in a better way. Whereas he is frustrated, he is angry, or he is sad, so there is a high chances of his harsh driving. So he might push a harsh brake, or he might do the more accelerations likewise. So that's the reason the emotional state of a driver is a very key concern in terms of the measuring the driver performance. Nowadays, the concept of smart cockpit has been come into the picture, wherein there are the different features are being offered for the comfortness or the safety of the driver. So we can consider this emotion detection, or after detection, we can plan for some proactive actions in terms of if we identify some sort of negative actions or the negative emotions. So this can be included as a smart cockpit concept. Uh, one of the observation or one of the analysis is also done that if the driver is in a positive impacting emotions, his response time in terms of applying a brake, or putting a acceleration, uh, is having a different reaction time than the when he is having some negative kind of emotions while driving. So it is always better to have a positive emotions when the driver is driving. So these are the objectives of this particular research, that we will be comparing the different deep learning models to identify or to detect the emotions. Then we basis onto the identified emotions, we can bifurcate it into the 7 standard emotions, and then basis onto the categorization of those emotions, we can take a further action. So in the facial expression also, the positioning of the face or the camera plays an impactful role to identify or to accurately identify the emotion. That's the reason the horizontal gaze and the vertical gaze come into the picture. The variation between the horizontal gaze and the vertical gaze will help us to identify the accuracy in the facial expressions. Also, we have an objective to have a real-time emotion detection system, so that we can deploy it into the vehicles and to identify and to use it in terms of increasing the safety. So the methodology that we have used is we have collected a we have collected a data which can be a real time. Then we have pre-process in terms of applying the filters, doing the augmentation, removing the noise, likewise. And then we are extracting a feature out of it. So here we are using the multi-input method. So for example, multi-input means the facial expressions that can be collected, as well as the physiological signals can be collected through the wearable devices such as a smart watch or likewise. And those will also help us to identify whether the identified emotion is accurate, or is there is a manipulation by the driver just to showcase that he is into the positively impacting emotions. Then we have trained the model by using the CNN and LSTM models. While training, we have followed the approach of 70-15-15, wherein the 70% of data we have used for the training purpose, the 15% data we have used for the testing, and the remaining 15% we have used for the validation. We have the performance evaluation was done by using the accuracy, the F1 score, and the minimum ERR. So the different model like CHD, wherein the horizontal gaze has been measured, we have used the CNN along with the horizontal gauge, and this has given, so this basically is with respect to the x-axis, the variation of the image, and this has given us the accuracy of nearly 69%. Next model that we have applied the CNN along with the vertical gaze, wherein the measurement of an image has been measured with respect to the y-axis, and we identified the accuracy has reached up to the 81%. Next, we applied the CFE model, wherein the facial expressions has been captured, and along with them, there is a highest accuracy which has reached up to the 90%, and there is a very lowest error rate we have identified, which is nearly 2.9%. Then the various combinations of the models we have used to test, and we found that the multi-model is giving us the better results. So these are some of the findings that we have identified. While applying the CHG, the horizontal gaze, we found that the accuracy of the aggressive, when the person was actually aggressive and it is identified as actually aggressive, was around 69.39%. And when he was a normal we can say he is a neutral and actually predicted was a neutral, was a 76.39. Similarly, when it comes to the vertical gaze, we found that it has accurately identified the aggressive behavior at 80.79%, which is nearly 81%, and the normal behavior was identified up to the 78%. When we have a facial expression combination model, we found that the accuracy has reached up to the 87.38% for the aggressive behavior, and for the normal behavior, it is 83.22. So in comparison, we found that CFE has the highest accuracy. Also, the CFE model is more deployable in terms of the real-time system deployment and the identification of the right results. These are some of the results that shows us the aggressive and the normal behavior of the person with the different models that we have applied. Coming to the conclusion, we have identified that deep learning model helps us to improve the accuracy and rightly identification of the driver's emotion. Then facial emotions are the key criteria, but there are chances that a driver can manipulate these facial expressions. So we are combining the physiological signals to verify whether he is accurately giving the expressions or not, and then we can verify the outcome or the identified emotions are truly identified or it is false. Then as we mentioned that multi-model input integration has to be done so that we can rightly identify these results. Yeah, that's all from my side. Thank you.
I think a very good presentation. And the topic that I was asking about with the other participant was actually what you emphasized that few. So I think a very good presentation. And the topic that I was actually asking for that other participant was actually what you covered. that how many percentage of the data was used for testing, how many was used for validation. So it's quite interesting, and I wish you all the best for publication.
Thank you, ma'am.
Okay. Thank you, Prashant. We are moving ahead with the next paper ID, that is 391, Muskan Bhatnagar.
Yes,
Muskan, are you
sir.
ready?
Yes, sir.
Please share your screen so that we will be able to assess you.
Is it visible, sir?
Yes, 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 it is visible now. Please go ahead.
Good afternoon, everyone. I am Dr. Muskan Bhatnagar. I am an assistant professor in Mangalore Institute of Management and Technology. My paper is titled as an empirical study on factors influencing online transaction in e-commerce, which is associated with privacy concerns and combining NCA and PLSM approaches. So the internet is an essential tool for the process of digitalization across various aspects of society. The digital revolution has fundamentally transformed commerce, making e-commerce an integral part of everyday life. It is a variety of characteristics such as interactivity, flexibility, and navigation. It is an explosive expansion in recent years, has been a major driver for development of retail and logistics sectors. However, the online environment also necessitates the disclosure of sensitive personal and financial information, which raises significant concerns about data security and misuse. As a result, many consumers remain cautious and hesitant when transacting online. These concerns have led to increased scrutiny of how platforms handle data privacy and security. Over time, extensive research have identified three psychological constructs, which are namely privacy concern, trust, and risk perception, as central to shaping consumer behavior in e-commerce. These factors play a pivotal role in determining whether consumers feel safe enough to proceed with transactions on digital platforms. The aim and objective of my paper is to explore and analyze the key factors that influence online transaction in e-commerce, focusing specifically on privacy concern, trust, and risk perception, using a combination of partial least square structural equation modeling, which is PLSM, and NCA, which is necessary condition analysis. The objective of my paper is to analyze the effect of privacy concern, trust, and risk perception on online transaction behavior. The second objective is to analyze the effect of privacy concern on trust. The third objective is to determine the necessary conditions for online transaction using NCA, which is to find out the necessity logics. And the fourth objective is to examine the mediation of trust between privacy concern and online transaction. The literature review is as follows. Firstly, privacy concern is referred to an individual's apprehension about how their personal and sensitive data is collected, stored, and used by online entities. It is driven by perceived lack of control over personal information and fear of misuse. Campbell in 1997 described privacy concern as a consumer's belief about what constitutes fair practices in data handling. Whereas Ullman and Armstrong in 1999 emphasizes that privacy is the ability to control access to one's information. Further, Gerber and Fatima in 2018 and 19 respectively suggest that privacy concern is heightened by frequent use of data breaches, phishing attacks, and surveillance. Then trust is the foundational element of online transaction, which is defined as the consumer's willingness to rely on e-commerce platform in presence of risk and uncertainty. Mayer in 1995 described trust as the willingness to be vulnerable based on the expectation that the other party will act in good faith. Jarvena in 2000 argued that trust is critical for online business success because it reduces perceived risks inherent in digital transactions. Whereas McKnight in 2002 presents trust as a multidimensional construct encompasses integrity, ability, and benevolence. Finally, this perception is referred to as a subjective evaluation of uncertainty and potential adverse outcome associated with online transactions. These may include concerns about financial loss, identity theft, unauthorized access of data, or performance failure. Chung in 2011 defined perceived risk as a consumer's belief in the likelihood of negative consequences from an e-transaction, whereas Mukherjee in 2007 categorized these online risks into two parts, privacy risk and security risk. Jarva and Todd in 1996 expand the construct to include social, financial, and functional risks. The model of my paper is as follows. The hypothesis development is as follows. For first, a privacy risk, the hypothesis one is as there is a significant positive impact of privacy concern on online transactions. Secondly, the second hypothesis states that there is a significant positive impact of privacy concern on trust. The third hypothesis is that there is a significant relationship between risk perception and online transaction. The fourth hypothesis states that there is a significant positive relationship between trust and online transaction. The outline of research methodology adopted for the present study is as follows. Firstly, the review of literature is done. Then the research gaps are identified. Then objectives are framed, followed by the quantitative approach. Then the purpose of the study is to test the hypothesis. The research instrument used in data collection is questionnaire. The pilot study was done on 40 participants. Then the final sample is 374 participants. Statistical techniques are used as SEM, structural equation modeling, and NCA, necessary condition analysis, which are the part of SMART PLS 4. The data analysis of demographics are as, this is the NCA analysis, is as follows. The effect size ranges from 0 to 1, which meets the certified limit. The demographics analysis is as follows. The male is identified for 67% and the female are identified with 32%. The age gap, the highest number of age gap is 18 to 30 years, which follows as 53.53%. Then the employment, the highest number is of service, which is 41.84%, and the highest number of educational level is at master's degree, which is 43.69%. Then the reliability and convergent validity is as follows. To test the reliability of the model, cron-batch alpha was used, which has a threshold limit of 0.7, which was met. For composite reliability, the threshold limit is also as 0.7, which was also met. And the factor loading was all above 0.5, and the average variance extracted was the threshold limit of 0.5 was also met. The discriminant validity is as follows. The Forner-Laffer criteria for discriminant validity, which requires the AVE of both constructs greater than the square correlation between two constructs. Hence, the discriminant validity was also met with all the variables. The findings of the hypothesis are as follows. All of the hypotheses were accepted except hypothesis 3, which was rejected, which is risk perception has a significant impact on online transactions. The hypothesis 5 shows a partial mediation. The conclusion of my study is as follows. The empirical study analysis, the relationship between drivers influencing online transaction in e-commerce platform. Privacy concern, trust, and risk perception were the main drivers of online transaction. It first examines the role of online transaction and privacy concerns using sufficiency and necessity logics on necessary condition analysis and partial least square equation, where it is told that the conditions are necessary and then further the sufficiency logics were tested. With the advancement of technology and increasing popularity in digital commerce, consumers' privacy concerns have become a significant factor in decision-making process with respect to e-commerce. It is also evident that addressing privacy concerns requires a comprehensive planning that includes mitigating risks, adhering to regulations, fostering confidence in customers, gaining competitive advantage, ensuring data protection and security, promoting awareness, and managing relationship between customers and service providers. The implications of the study is as follows. Firstly, it improves the e-commerce business strategy, so the managers can make better strategies related to privacy concerns. Then it gives insights to consumer behavior and trust building measures. Then the customer satisfaction and loyalty is also increased. Then the influence on academic research and potential regulatory impact can also be increased. Then fifth is consideration of cross-cultural differences and ethical practices in e-commerce can also be increased. The recommendation for future research through this paper is as follows. The study is basically on customer-centric approach. Therefore, service-centric approach can also be included. Various variables that can also expand the study, which are cyber fraud perception, customer satisfaction, purchase intention, can also be incorporated for identifying actual consumer behavior. Then the study has been done on e-commerce platform, but various other channels like m-commerce or social media commerce can also be tapped on. This study also utilizes only the online survey as a research method. So the limitations of the research can also be fulfilled by including with other types of questionnaires or survey methods. Subsequent research should expand on these findings and investigate further into stages of e-commerce and customer journey, as it does not include customer journey. Thank you so much.
Thank you so much, Muskan. So what was the
Thank
sample size that you took?
374 participants.
Okay. And everybody was online. So did you do a pilot survey for that?
Sorry, ma'am?
Did you do a pilot survey before finalizing?
Yes, ma'am. Yes, ma'am. 40 participants were there for pilot study. And also question was asked, do you use e-commerce or not? If they don't use e-commerce, then the questionnaire was resolved at that time.
How is your study different from all the studies of e-commerce that are already prevalent?
Ma'am, in my study, I have used NC analysis, which tells, sorry, ma'am.
Nothing.
Hello?
Yeah. How is it different?
Ma'am, I have used NC analysis, which is one of the first analysis which is combined with PLFM. So NC analysis focused on necessary conditions, which are a prerequisite of giving the answer if the conditions are necessary or not, and then further the sufficiency logic has been used. Also, risk perception has been a factor in influencing online transaction. So it differentiates other studies from my study.
Okay, thank you.
Thank you so much.
Okay. The paper ID 286, Arun Prabhakar.
Hello.
Yes.
Give me a second.
I can listen you. Please. Yes.
Am I
Please share
visible?
your screen also. Yes, you are visible.
Is it visible?
Make it a full screen.
Yes, sir. So let's start.
Yes, yes, yes.
Okay. Good afternoon. My name is Arun Prabhakar. I'm from MIT University, Uttar Pradesh. And today I'll be presenting my research paper on automated video subtitling and translation using Whisper and Helsinki models. This project lies in the intersection of accessibility, artificial intelligence, and real-world video content delivery. Um, with the exponential growth of video content online, be it social media, news, education, or entertainment.
3 o'clock. I'm in the
there's
conference.
There's a growing need for this content to be accessible across languages and for people with hearing impairments. Manual subtitling and translation is a tedious, time-consuming process that lacks scalability also. So artificial intelligence steps in to automate speech recognition and translation to provide fast, scalable, and multilingual solutions. Let's move on to research gap. Despite advances, existing systems will still face significant challenges, such as many models fail in noisy environments or where the accents vary from each other. Non-English contents is still underrepresented in training data, leading to poor transcription accuracy. And there are very few pipelines that integrate both transcription and translation smoothly while maintaining the alignment of the subtitle with the video or the screen reader with the video. So these gaps motivated the development of more integrated and AI-based transcription and translation system. And the objectives of my project were to automate the subtitle generation from raw video input, to use Whisper, which is a state-of-an-art ASR model developed by OpenAI for transcription, and then seamlessly use Helsinki NLP model, which which is specifically Opus MT for machine translation for high quality translation to ensure the generate subtitles are accurately timed and semantically correct. And finally, to evaluate the system's performance under real world conditions. The tools and technologies I used were OpenAI Whisper for translation. The Whisper ASR automatic speech recognition model developed by OpenAI is a transformer-based system which is designed to handle diverse speech recognition tasks. It has been trained on 680 hours of multilingual and uh, multitask supervised data collected from the web, which makes it one of the most versatile and accurate open source speech to text solutions, which is available today. Uh, its architecture makes it particularly suited for handling long audio sequences and complex speech patterns. Next, we have used Helsinki NLP model, which is Opus MT for translation. It is also based on transformer architecture that accelerates sequence to sequence tasks like machine translation. The Opus MT model supports over 1,000 language pairs, making it much more versatile than what's available in any other technology or sequence in today's market. In particular, they are fine-tuned for transition between high resource languages. And another tool we have used is FFmpeg. It is a powerful open source multimedia framework which we have used for audio extraction and subtitle format generation, as well as embedding the subtitle into the original video. Uh, it is widely used for handling audio, video, and other multimedia files and streams. In this system, it served as the backbone for pre-processing and post-processing video data. We have used Python for building the pipeline. This is the system architecture for our pipeline. The diagram represents how both the models are integrated to perform transcription and translation simultaneously. As you can see, the output of the Whisper ASR model tend to be longer than the optimal input length of the Helsinki translation, especially in case of longer sentences. Hence, we approached this discrepancy with a chunker. It breaks apart sentences in smaller phases while preserving the context as much as possible by focusing on grammatical aspects like use of conjunction, preposition, and so on. This design supports both single and batch processing that can be run on CPU or GPU environments, although the GPU environment will be much faster and efficient at both translation and transcription. Let's move on to methodology. So first of all, the video is fed in the pipeline. The audio containing the speech is extracted from the video while avoiding picking up as less noise as possible. This is done using the open source multimedia framework known as FMPEG. Then this extracted audio is passed on to Whisper model, which transcribe the speech into text while also preserving the timestamps for each sentence or part of sentences. Then the Helsinki OpenMT model translates the transcription into a desired target language or languages. The translated text is then formatted into SRT format and stored as a subtitle file, which can be used separately or by default we embed it into the original video that was provided into the pipeline using FFmpeg. And after that, we perform performance evaluation using metrics like WER, which is word error rate, and BLEU score, which is bilingual evaluation under study. This method was tested across different video types and languages to ensure generalizability. Here I have some sample results. For example, I tested a video of Donald Trump's interview on CNN. The system was able to accurately transcribe its speech even with background noise and interruptions. Once transcribed, the subtitles were successfully translated into English, French, Hindi, and Japanese, and overlaid with proper timing alignment. This demonstrates both the linguistic and technical capability of the pipeline. Let's move on to analysis. So for the following evaluations were done mainly across the few dimensions. The accuracy. Whisper achieved a word error rate of around 4.6% for English, which is close to human level performance. For languages like Spanish and Hindi, the word error rate were around 12 to 18%, which is still better than many open source systems. The top performing languages for whisper transcription were English, Italian, German, and Spanish. The mid performing were French, Portuguese, and Japanese, while the worst performing languages were Arabic and Hindi. The translation accuracy is represented by the BLU scores for subtitle translation, which range from 0.75 to 0.85 for common language pairs. This shows that the system performs reliably across different tasks and languages. Whisper, for my key findings, the Whisper is highly accurate and robust even in noisy environment. It slightly staggers with accented speed, but still performs relatively well than its other competitors. Helsinki NLP provides the comparative translation quality even for like subtitle and switches. The system process the for the timing and scalability, our system processed a 10-minute video in 12 to 35 seconds, depending on GPU availability. If the GPU was unavailable for the system, it would take like slightly longer, around 50 to 75% more time. Scalability is so that it can handle batch and parallel jobs efficiently in production scenarios. These are the real implications of the project. It can greatly reduce the cost and time required for subtitle generation. It also can make the content more accessible to global audiences and people with hearing impairment. It can be integrated into educational platforms, media production pipelines, social media platforms to support multilingual content delivery at scale. Let's move on to the limitations. The Whisper model requires significant computational resources, particularly for processing large, uh, longer videos. Also, it performs well in general scenario, but may struggle with specialized domains like medical or legal terminology unless fine-tuned. Whisper accuracy drops in highly noisy environments, though it remains usable. The system still struggles with a low resource language like Bengali or Swahili. Despite the high performance of the Opus MT model, particularly in common language pairs, automated translation continues to face several persistent challenges. These challenges are primarily linguistic, cultural, and data related. For example, idiomatic expression pose a significant challenge for machine translations. For instance, an English phrase like kick the bucket, which means to die, may be translated literally into other language if the model had not been trained on idiomatic equivalence. Such translations are not only confusing but also may lead to uh, misinterpretation in subtitle videos. So the future work could focus on adding language specific fine tuning, real-time subtitle generation, as well as better UI UX for non-technical users. Thank you for your time and attention. I would be happy to take any questions.
Well, I think it's a good research, and you should carry it out for some good journal publication.
Okay. Thank you, ma'am.
Oh, thank you, Arun. So now we are moving ahead with the next participant, Dr. Richa Sharma, paper ID 412. Dr. Richa.
Yes, sir. PPT कहाँ गई?
We are not, yes. Please turn on your camera also. Yes, ma'am. Please
Yes, sir.
go ahead. Yes, please.
Yeah, good afternoon, sir. Well, I'm here to present my paper on energy efficient artificial intelligence, delivering green technologies for a sustainable digital future. And here I am with the introduction to the topic. The concept of green AI has emerged as an approach focusing on developing energy efficient models and optimizing hardware, data centers, and algorithms. AI these days is a beneficial force for innovation without compromising the environmental sustainability. Green AI promotes a future where advanced technologies are aligned with climate goals, making digital progress compatible with planetary health. I'll not go into much detail of this slide, but yes, altogether we have come to learn that this AI models are demanding enormous computational resources, emissions of carbon dioxide, and we are facing such problems. Green AI addresses this by promoting energy efficient models like Green in AI and AI-driven environmental solutions, Green by AI, to reduce carbon footprints and support sustainable digital development. The concept of green AI, it refers to an application and development of intelligence technologies that support environmental sustainability. It helps implementing initiatives like Green Deal, greenhouse gas and improving efficiency in, in sectors, it's not visible.
Ma'am, your slides are not changing.
Sorry, sir?
Your slides are not changing, actually. Are you on the slide number 1 or?
No, sir, I'm on this slide. I hope this is
okay, fine.
visible.
Yes. Please. Yes.
Sorry. Yes, initiatives like Green Deal by reducing greenhouse gas emissions and improving efficiency in sectors like energy, agriculture, transport, and urban planning. AI supports climate action through forecasting, smart grid management, and precision agriculture. The objectives with which this research has been done are as on the screen: to understand the current applications of AI in energy systems and discussing future advancements needed to achieve sustainability goals in energy, to investigate AI's potential to reduce waste, improving recycling rates, and support the development of circular economy, to explore how different countries are integrating these sustainability into AI development and using AI to solve environmental challenges, to understand how AI can enhance waste sorting, recycling, and contribute to the development of the circular economy, reducing landfill usage and promoting resource efficiency, and to highlight the opportunities for global partnerships to accelerate AI-driven solutions for environmental sustainability. Now here I take, what do we mean by green by AI? It is referring to the use of AI technologies to enable, enhance, or accelerate environmental sustainability and climate actions across various sectors. And what do I mean by green in AI? It refers to the efforts to make artificial intelligence itself more environmentally sustainable by reducing its energy consumption, resource usage, and carbon footprint during the development, training, and deployment of AI models. What I have taken is basically the difference between both the terms green in and green by algorithms, and of course how are they affecting us. Now comes the evaluation of green in versus green by algorithms. The difference is, as can be seen, is the distinction between how AI is made sustainable, which we talk about in green in concept, versus how AI is used to promote sustainability, which we talk about in green by concept. I can take a few key differences, like in case of green in AI, which is focused on reducing the ecological footprints of AI systems themselves. We can talk about, this includes like energy efficiency, working on the reducing the amount of energy which is required in these AI models, carbon footprints, that is reducing the carbon emissions, hardware optimization, designing specialized chips and processors which can be more energy efficient, and algorithmic improvements. These were a few focuses while we are talking about green in AI. And now if we talk about green by AI, it is leveraging AI to make other industries and processes more environmentally sustainable, which includes climate change modeling, smart energy management, sustainable agriculture, wildlife conservations, and circular economy. I have taken a few examples from companies like Google's AI for energy efficiency. What are they doing? Google has worked on making its data centers more energy efficient using AI algorithms. In 2016 itself, Google applied DeepMind AI to predict and optimize the energy usage of these data centers. And the outcome is that the AI system has been able to reduce the energy used for cooling by 40%, significantly lowering the overall energy consumption. And Google has also committed to running its data centers on 100% renewable energies. Google uses AI to manage power distribution, optimize energy use in its infrastructure, helping to reduce the carbon footprint. Another is Microsoft's carbon negative by 2030, wherein Microsoft wanted to address the large environmental impact of its AI infrastructure, including the power consumptions of its cloud services. The solutions that Microsoft has applied are Microsoft has implemented AI-powered energy optimization systems to improve the efficiency of the data centers and is committed to become carbon negative by 2030 using AI to help analyze and optimize the energy consumption and reducing the carbon emissions. AI models and Microsoft also helps in tracking and reporting their carbon emissions as well as improving energy management across their data centers. If I talk about green by AI, I have taken up the example of IBM's Green Horizons, where the global community is facing the challenges of predicting and mitigating climate changes, and climate models are complex. Solution is that Green Horizons program that has been launched by IBM is using AI and machine learning to provide advanced climate modeling, air quality predictions, and energy consumption optimizations. The AI models analyze data from satellite sensors and weather conditions to predict environmental trends, including air quality, renewable energy production, and potential climate change impacts. The outcome has been that AI-driven climate predictions have helped cities and industries to make proactive steps in reducing pollution and improving sustainability. And next, I take up the wind energy. Google's initiative again for wind energy, again through Green by AI. The problem is the variability of the renewable energy sources like wind and solar, which make it difficult to manage the supply and demand. Solution, Google is using AI to predict wind energy patterns and improve the efficiency of wind farms. They have developed an AI system which analyzes weather data to predict wind conditions hours ahead of time, which is helping to better match energy production with demand, reducing the reliance on fossil fuels and improving the grid's stability. The system has led to 20% improvement of efficiency of wind energy production. Next example I'll take up is from the ocean conservation. Again, this is being done by Skyfish, the ocean agency Skyfish, who are using drones to monitor oceans and marine life. These drones can detect changes in marine environments, track endangered species, and identify illegal fishing activities. And of course, this is somewhere helping in preserving or conserving the endangered species. Now, few data from the countries, the valuable insights into global trends, as the topic tells you, is that I have taken a few examples from the some countries also, wherein these green in AI and green by AI initiatives are being implemented, like United States. Green in AI initiatives, I would comment, I would quote Microsoft, which is committed to being carbon negative by 2030. I have already spoken about that. Google achieved 100% renewable energy sources, and NVIDIA focuses on designing energy efficient hardwares like A100 GPUs, which are optimized for AI workloads and reduce energy consumption. Green by AI, if we talk about the US itself, climate change research the Environmental Protection Agency and other organizations are using AI model to track the air quality and the climate change. Agriculture, AI-powered platforms like Farmers Edge are helping optimizing water usage, reduce pesticide use, and improve crop yields. And energy, in case Google DeepMind collaborates with energy providers to improve the efficiency of wind farms and integrate renewable energies into grids. Now, a few examples from European Union, wherein Germany is leading in AI hardware and energy efficient computing. Companies like Siemens are integrating AI with energy systems to reduce consumption. France and similarly Netherlands. Next, in Green by AI, I would take up climate and environmental policies, which the EU is spearheading green AI applications with initiatives like Horizon Europe, which funds research on using AI to tackle climate change and biodiversity loss. Precision agriculture is again and prominent in countries like Netherlands, where AI is helping to optimize their water usage, reducing emissions, and ensuring food security in a sustainable manner. Renewable energy. The European Commission is supporting projects which are used to use AI to integrate renewable energy sources into grid. The A14 EU project is dedicated to AI-based climate and energy solutions. Now I talk about India. Green in AI initiatives like Tata Consultancy Services are developing AI technologies for energy efficient manufacturing and sustainable urban solutions. And Wipro uses AI to improve energy efficiency in the IT infrastructure it operates, focusing on reducing the carbon footprints of its data centers. Green buying initiatives, AI initiatives in India, like in agriculture, AI-powered platforms like AgNext are there, which are helping Indian farmers with crop disease detection, weather forecasting, and better resource management, ensuring sustainable farming practices. Solar energy, AI is also helping optimizing the solar power plants with companies like Sterling and Wilson integrating AI-based solutions to improve the efficiency of the solar power generation. And Smart Cities mission is leveraging AI for urban planning, traffic management, and waste management in cities like Bhopal and Surat to reduce the environmental impacts. In case of Japan, we can take examples of Sony and Fujitsu. Like Sony focuses on developing energy efficient AI and smart home devices. And Fujitsu has introduced AI-powered energy management solutions that are helping businesses optimize their energy usage and reduce the costs. Green by AI initiatives in Japan are like taking up smart grids, robotic waste management, and agriculture. In South Korea, I have taken examples of Samsung and LG again. And it's just similar in South Korea also, Green by AI, smart cities, they're focusing on smart cities, renewable energies, and climate monitoring. So the suggestions based on these country-wise comparisons and trends in AI for sustainability, there are several suggestions for further enhancing green in AI or green by AI across different regions. And we can have a look on these, like promoting energy efficient AI development, to developing energy efficient AI frameworks, investing in AI optimized hardwares. AI for renewable energy optimization is the other suggestion, which can be done through smart grids and energy management and AI-driven demand response. Third suggestion is AI for climate change and environmental monitoring can be also looked forward to. AI for early warning systems and by developing real-time pollution monitoring. AI in agriculture is the fourth suggestion for sustainable practices where you can use AI-powered precision agriculture or sustainable fertilizer use. Similarly, AI for circular economy and waste management is another recommendation. Through AI optimized waste sorting and for AI for circular economy. Sixth, AI-driven smart cities for sustainable urban living, wherein smart transportation systems and AI-enabled smart buildings can be taken up. And last suggestion which comes up is as international collaborations on green AI can take place for global AI sustainability alliances and knowledge sharing. The conclusion here is that for countries looking to strengthen their AI-driven sustainability initiatives, there are key opportunities in energy-efficient AI development, renewable resources optimization, precision agriculture, waste management, and smart cities. Collaborative international efforts will also be critical in scaling these solutions globally. Thank you.
Thank you so much, Dr. Victor. I must say it's a very interesting topic that you have worked upon. Yeah, so I think it has huge potential, and if you build up a model or something, across it, I think this will be one of the prime first publications in that particular area.
Thank you, ma'am. I am still working.
Good luck.
Thank you.
Okay, thank you, Dr. Richa. So now the next participant is paper ID 413, Aanchal Tyagi. Paper ID 413, Aanchal Tyagi.
Yes, sir.
Yes, please go ahead. Turn on your camera also.
Yes.
And make it a full screen.
Is it visible, sir?
The screen is visible to me, but I'm not able to see you. And make the screen a full one so that we can see that properly. Lot of noise near you. Can we start, Dr. Aanchal, now?
Yes, sir.
Yes, please. Please go ahead.
Is slide is visible, sir, now?
Yes, ma'am, it is visible.
Good afternoon, everyone. My name is Dr. Acha, and the topic is mine is sustainable HR practices through green technology, the analyzing employee perception.
There's a lot of disturbance from background.
Now, ma'am, is it okay?
Yeah, yes, but
So, ma'am, basically the paper is all about the sustainable human resource practices, that is specifically through the lens of artificial intelligence and gamification. Basically, the motive of this or objective, we can say the paper investigate how these technology are influencing job stability from the employee's perspective, an area that is increasingly relevant in today's evolving workshop. So, if we start with the introduction, the artificial intelligence enhance HR by improving decision making, streamlining process, and offering personalized employee experience. It automates candidates screening and tailors training programs to individual learning needs, strengthening talent management. The third is ethical concerns such as bias and job security, risk highlights, and the needs for transparent, responsible AI implementation. The research paper, when we're doing this research paper, the question we have in our mind is the how do HR professional perceive the role of AI in HR? Or we can say what are the benefits and risks associated with its AI use in HR? Or the most importantly, can AI and gamification help guarantee job security rather than threaten it? Because the job security is the basic and main issue in our present scenario. So if we discuss about the AI in HRM, so I would like that it has automatic recruitment, customized employee training, and manage performance metrics in real time. While the second, the keyword is for my research paper is gamification, which use elements like points, badges, and leaderboards to make routine tasks engaging. So while these tools are improving, or we can say improve efficiency and motivation, they must be implemented with responsibility to avoid increasingly employee anxiety about their job future. To survey this, I will go through with the different literature review with the keywords of gamification make HR process more appealing, or the AI can disrupt job roles, or it will help, or it will be in a pros and cons area. So during my research, I used the sample size of 400 HR professionals, which is from Greater Noida across like industries like banking, IT, healthcare, and retail. For this, I used a four-part questionnaire which measured on a Likert scale and analyzing the data with the SPSS and AMOS. So when I do this all research, I would I like to generate a hypothesis The three hypotheses I request is that employees' perception of AI and gamification affect the feeling of job security. And the hypothesis 2 is the AI, when properly integrated, has a positive effect their feeling of job. And the third is that the more secure employee feel, the more positively the way gamified HR practices. When I do this test with Amos and yeah, there is a statistical key findings. When I do this, firstly I have to find a PAL HRM, that is a perception about learning HRM, and the other is perception about gaining value through HRM, and the third is job involvement and satisfaction. When I use the Cronbach alpha test for this, the data conclude with the findings I have found that PLHRM is 9, which is highly relatable. The alpha is greater than 0.9, that can be say it will be the excellent, or we can say the perception about learning HRM is in a favoritism. So when do we do a PGV HRM? So it is a alpha between 0.8 and 0.9, as you see on a screen. It is also a good, and the jobbins is also accepted, which shows the good reliability. So we can say that a higher value indicates that the items measure the same underlying constraint. So by the Cronbach alpha result, I conclude that these all three have a high reliability as their Cronbach alpha values are above 0.8. This means an item used under each dimension are consistent and reliable for measuring what they intend to measure. After that, on the second, I use a descriptive statistic with the help of mean, median, standard deviation, skewness, and kurtosis, in which I found the result positive also. And the third is multiple linear regression model, in which the result also indicates a good convergent validity. So by all these research, by all these analysis, I found that the measurement model is statistically sound and effectively. If we discuss about the dual narrative or transport communication ethical framework, so there is a both AI and gamification were positively correlated with job security. So the basic objective of my research paper is to find out the AI and the gamification is helpful in a job security or not. So after result, I found that it will helpful. And the model has a strong reliability with a Cronbach alpha value that is 0.84. So I have that value is 9. So it is also be relevant for this study. And the model fit was excellent, which includes 4 factors that is intended. So all the support, all the result, all the findings are supporting my hypothesis, which has to conclude me that AI is making HR more efficient and data driven. Even gamification is making tasks more engaging, but these benefits can backfire if employees fear they are being replaced or constantly evaluated. So the ethical implementation, if I would like to say, the communicate openly, the HR should communicate openly, involve employees in the transition, and the offer training and upskilling opportunities. So if I'm going to conclude the research paper of mine, data, AI, and gamification have great potential to make HR practices more sustainable, and organization should be balanced technology with empathy. And I would like to say prioritize upskilling and communicating transparently to reduce fear and resistance. The human tech balance is the key to both performance, psychological safety of the workplace. While during my research, when I use a statistical analysis using SPSS and AMOS, it also confirmed the reliability and validity of the measurement models. So with the strong factor leading and high internal constituency, AI enhanced decision making and personalized training, while the gamification is also help for boosting engagement and morale. So both the ethical concerns and the job loss remains. Overall, we can say, or the paper can conclude, or paper is also concluding that the balanced, transparent implementation to maximize benefits and ensure workforce stability. So the objective, as I already said, the first point is the HR professional perceive the role of AI and HR and the benefits and risk and the gamification of affect employee engagement. So all are like, yeah, gamification affect the employee engagement, but in a positive way. Or I can say AI and gamification help guarantee job security rather than the threaten it. So here I conclude my research paper, ma'am. Thank you.
Thank you so much, Dr. Anshul. And I think indeed interesting work about HR practices. I think HR is one aspect in which the potential of AI is quite unexplored. So good work,
Sorry,
ma'am.
ma'am. Sorry.
study in total?
Hello, Vanika ma'am.
Hello.
Your voice was breaking at that time when you were saying something. Can you suggest something? I think there is some network issue from Vanika ma'am's.
Is it
Hello.
better now? Can you
Yes, 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 yes. It is now better.
As I was saying that it's quite interesting to see AI applications in the HR area. So HR is somehow the area in which the AI applications are quite less in number as opposed to operations and other fields. So good work, ma'am. Thank you.
Yeah.
Okay. Okay. Thank you, Achal Tyagi ji. Thank you.
Thank you so much.
Okay. So next is paper ID 166, Anurag Chaturvedi. Anurag Chaturvedi, paper ID 166. Then next is paper ID 158, Ramakrishna. Paper ID 158, Ramakrishna. Then the paper ID 19, Tariq Ali.
Hello everybody. Tariq is not available and I would like to present today. We work together on this paper.
Okay, not an issue, sir. Please turn on your camera and share
Sure.
your screen with the presentation.
Okay, I hope you can see me, okay?
Yes.
Let me share my screen.
Yes, we are able to see your screen. Please make it a full screen. Yes, please go ahead.
Okay, great. So my name is Farid. Today I will talk about the cloud-enabled educational transformation, designing and implementing comprehensive framework for the learning institution. I work with the Tariq, Fatin, and Allah Abdul Fikar Zoltan. And so I would like to talk about first the motivation, why we need work on this project. Because traditional infrastructure costly, inefficient, and hard to scale. And its need for the remote learning and scalable systems. And the main goal is to use OpenStack to build effective cloud framework. So the main objectives include to implement practical cloud infrastructure, reduce the cost. As we know today, the cloud service, it's really expensive, specifically Amazon, GCP, Azure, and reduce cost and optimize the resource, enable remote access to learning, and improve administrative collaboration. So why OpenStack? OpenStack today is very popular and it's very good. As I mentioned, it reduced the cost and it's open source and cost effective. Modular components include the Nova, Neutron, Glance, Keystone. It's really let's say it contains too many components which you can install separately what you need, and it's suitable for research constrained institutions. And for set up the OpenStack, or let's say installation of the OpenStack is not so easy procedure. You need to have a very good the server or maybe a very good device, and that's why we choose the server Ryzen 16 GB RAM, and the clients we use HP EliteBook, the Xiaomi 11T Pro, and network we use the TP-Link router, and software we use the CentOS. Actually, it was good. We can use also the Ubuntu, but we choose just CentOS and OpenStack and Proxmox. So Nova is containing the virtual management and Neutron networking, Glance image repository, Keystone identity management, and Vinci for remote access. It's for the providing access to external users. The implementation flow consists of in 6 main steps. First, the hardware setup, operating system installation. As I mentioned, we use the CentOS. deploy OpenStack services, create virtual machines, and enable remote access and test in real-world settings. So the use case trial is a concept. The first week we spent the deployment at mid-sized institutions. The teachers easier the course management and students seamless resource access and insight need for more staff and training, let's say like this. And the key benefits include scalable and flexible, accessible from any device, lower infrastructure cost, enhance the teaching and the learning in the system, and proof of concept for growth. So in conclusion, we can say it is a cloud setup available with modest resource. OpenStack is stable, scalable, and supported. Today, as I mentioned, it's very popular. Many big companies using the OpenStack, and it's enable modern educational experiences. And in the future, we are planning to improve the security and also broad integration with the another components. That's our future plan. And that's all. Thank you.
Okay, thank you so much. I think you need this is more of a working paper that is there.
Sorry.
I think I don't have any questions. Thank you.
Thank you. Thank you very much.
Okay, thank you, Farid. Let's move to paper ID 414, Ekansh Agarwal.
Yes, I'm presenting in 1 minute.
Okay, fine.
Okay, anyone else left after the count?
Yes, ma'am. क्या कह रहे हैं?
Anybody else left after the count?
After Ekansh, we are left with two participants, Anurag Chaturvedi, paper ID 166, and Ramakrishna, paper ID 158.
I don't think they are here.
Let me see whether they are the part of this meeting or not.
I am not able to see them.
No, we are not able to see them. Okay.
Hi, can you give me 1 minute? Sorry
Yes,
for
please,
the
Ekansh, do it fast so that we can complete the task on time.
Hello, is my screen visible to you?
Yes.
So the topic of our paper is sustainable computing for future-ready engagement. So we have integrated green technologies and try to make a digital ecosystem for this. So this entire frameworks can drive participation and high quality content contribution in online communities. So we have taken case studies on government agencies and online platform, which is designed to support welfare recipients transition into employment. So our analysis cover both technical and social impacts of integrating batch-based gamification on user engagement and content quality. So, what is gamification is defined? It is use of a game design elements in non-game context to boost motivation and engagement. It leverages and rewards like badges and points to incentivize user behavior. Second, sustainable computing. So it focuses on minimizing environmental impact through energy efficient hardware, green software practices, and eco-conscious data management in digital systems. Digital ecosystem is a complex network of interacting digital communities and technologies that evolve dynamically, supporting collaborative knowledge and resource sharing. So the frameworks we have used in this paper is badge-based reward system and contribution quality measurement. In badge-based reward system, we used to give digital badges as a tangible movement in recognizing member contribution and milestone. And for quality measurement, we are using AI tools for evaluating content relevance and quality. So first case study that we have taken is a welfare recipient through gamification. So we have made an alliance between government agency and a online community to aid welfare recipients through employment transition through structured engagement. So in that platform, we have implemented badge reward system, and we have assessed and personalized, made a assessed and personalized user-based dashboard for tracking progresses. For this, participant benefited through like they are encouraged for continuous learning and networking, increasing access to resources and digital literacy. Uh, so impact of gamification on user participation is that first is like through its initial launch, moderate user activities, platform initialize, community dynamics. Second, batch introduction, significant boost contribution, increasing more reachability and it also boosts motivation effect. We use advanced AI integration also in this. We improve relevance and user engagement. Fourth, we use sustained engagement, in which ongoing user retention and high quality contribution stabilize community growth. This is our analysis on content quality versus contribution metrics. So this shows that the people, the users are engaged more towards the reply based and reward based systems. So challenges that we face is our technical complexities, user diversity, environmental impact, and long-term engagement. And in the last, we are like trying systems in which we are like we wanted to out increase our outreach to various communities and integrate them into a single larger community so that they can benefit from these services.
Okay, thank you. Nikhil sir, anyone else left for the presentation?
Hello, ma'am. One more student is coming, ma'am. Just wait for a minute. I think. बोलो अभी ज्वाइन करें
ये स्टार्ट हो रहा है एंड हो रहा है सर?
वेट करें सर, 2 पार्टिसिपेंट्स रह रहे हैं।
अच्छा अच्छा।
हेलो सर, हाउ आर यू?
हेलो हेलो, कैसे हैं आप?
बस बढ़िया सर, आप बताइए।
गुड टू सी यू आफ्टर लॉन्ग टाइम।
I came to Amity also a few weeks ago. I think
अच्छा
उस दिन आप मिले नहीं मुझे।
अच्छा अच्छा, आपने बताया नहीं आप आए। और एपीजे में क्या चल रहा है? ठीक।
Good, all good sir.
यहाँ भी ठीक है, लोग वेलकम बैक कर रहे हैं, आना।
I'm happy where I am.
दैट इज गुड, दैट्स गुड। और नया रिसर्च माइलस्टोन क्या है आपका?
सर अभी तो कहाँ, अभी तो बस वहीं पे।
चल ही रहा होगा। आप कितना एच इंडेक्स 25?
इतना भी नहीं पहुंचा सर, थोड़ा कम।
अच्छा अच्छा। नावे सर इज दैट नो, ही इज डूइंग।
नहीं, हम 20 के आसपास है, बट 25 अभी पहुंचा नहीं है।
दैट्स ग्रेट। हम भी पहुंच गए 8 तक धीरे
सर
धीरे।
आप तो तेजी से निकल रहे हैं, अभी हमें तो सालों लग गए।
नहीं, just all your inspirations.
Okay, Anurag, can we start now? Please unmute yourself and then you can share your screen.
Yes, good afternoon, sir.
You are audible here, please start.
Sir, I am give the paper by with the different title by changing the title according to my guy's name, but I give the title this multimodal emotion recognition in rehabilitation treatment of disease using different AI technologies, where I combine using the different modalities. By understanding the different emotion recognition technologies, we can get the different emotions that get from the different modalities by combining them for the telerehabilitation purpose. In this, we have used the text modalities, audio modalities, visual modality, and the movement modality, where we used to make here use these technologies for the emotion recognition and combine them for the telerehabilitation treatment of disease. Here, here we use for the text analysis the BERT model for the natural language processing like model, where we will detect the text emotion and what kind of emotion get from the text, the people sentiment from the text, and we use the word to back for the audio analysis and to capture the emotion from the audio signals and from the pitch of the audio. And for the image, we use the just like CNN like model and ResNet like model for the visual visual features detection from the facial images, detect how the reaction shown by the people from their face, and by combining them we make the system, we make a model for that, that is text, audio, and visual modalities to get the correct modalities for the emotion recognition.
Is it done, Anurag?
Sir, no, sir. I am delivering some more. The facial feature extraction and recognition, just like real-time facial landmark detection, where we use the real-time monitoring by the people that we use for the tele-rehabilitation by getting to know the real time by making a model in the future. It is for the future by real time detection for the tele-rehabilitation, advanced classification models like SBM and random forest. By integrating it in the tele-rehabilitation, we can use it for the tele-rehabilitation and tele-rehabilitation treatment or therapy for improving the patient engagement, and it can also save the time of the people by getting the tele-rehabilitation from their home, those who are much farther distance for moving, not having such kind of moving abilities for the longer distances. Next slide.
Is the PPT over?
And second, uh, the data augmentation techniques, how we can diversify the data from the data set that we have to get the data by changing uh, by some changes in the data. We get if we have not enough data, we can increase the size of the data by using the data augmentation techniques. And the dropout layers that we use to prevent the overfitting and ensuring the generalization to unseen data and maintaining high accuracy. Uh, for making this, we can use the TensorFlow and Keras, the libraries, which are flexible and scalable for developing and making and deploying that this model. Multimodal approach of the CNN and the BERT, integrating the CNN for the visual and BERT for the textual, and BERT for the textual employs the we can employ the BERT model to analyze and interpret emotion from the text, and CNN for the visual, and we have demonstrated the super performance on diverse data, showcasing a robust model. We can train the data on the different data set that we have get from the Kaggle to get the better context about the emotion recognition on that data. We can use the recurrent neural network. These are the futuristic approaches that we can added in our tele-rehabilistic system for the future, so that we can get the EEG signals for knowing the unconscious patients by getting the EEG signal getting up and down when some patient got or something. Unconscious means that the patient either is in coma. If we got something feedback the patient is hearing or not us. So if the patient is hearing, the EEG signals got changed, sometime high and low, so that we can understand that the patient can hear us. If he cannot make a movement by their body. LSTM network just like for the real time. If we go for the real time, we can go with the LSTM for the temporal dependencies and enhances the emotion contextual understanding. And the word to web also we can used for the same kind of text embeddings to get the better emotion recognition from the tone of the textual features that we got in the text data. And ensemble learning combine multiple models through ensemble learning ensures a robust performance that lead to the accuracy in emotion recognition tasks. Attention mechanism in multimodals. We can harness the AI to enhance emotion recognition in across different modalities. We can prioritize our features that have better for the emotion recognition, and to use the better data set and integrate them for making the tele-rehabilistic model. In this, we have also some ethical consideration that we have to always make it so that the privacy concerns are always safe. So data collection for emotion recognition raises significant issues, necessitating strict protocols to safeguard user information. The biases in training data set, inherent biases in data inaccurate emotion recognition, highlighting the need for the diverse and representative data. Transparency and explainability, transparent and explainable to trust and understand the user, how decisions are made, so that the people who either got treated by the telerehabilitation that we have, that person have the trust. So for the we can build the trust by the transparency that we go the right direction. He can see the progress, how we are doing, and ethical deployment involves the assessing potential impacts of users and society, promoting responsible AI use in real world applications. Future directions. Enhance multimodal fusion techniques, integrating various types of data improves emotion analysis, lead to more accurate outcomes. Real-time emotion recognition system, developing system that can access emotion instantly, enabling timely responses in application. Broader application in healthcare and entertainment, expanding the use of emotion recognition in therapy, mental health monitoring, and immersive experiences. Addressing ethical and biases challenges, implementing the strategies to mitigate biases in AI model, ensuring fair and ethical use of the technology. That's all, sir. Thank from my side.
No questions.
Okay, okay. Thank you, ma'am. Thank you.
Thank you. Thank you.
Vanessa 158 is.
Sir, can I leave?
Yes, yes, you can leave.
Thank you, sir. Thank you.
So are we waiting for someone?
One participant is left. हाँ वो आ रहा है. Okay, thank you, Varnika ma'am and Zobida ma'am. Thank you for your valuable time for 3 hours. I know that it is very hectic 3 hours, that too in the online mode. In the offline mode, we have that opportunity to interact with the participants as well as the organizers, but in the online mode, it could be a bit difficult task to be engaged for 3 hours continuously. But thank you for your valuable suggestions to the participants. Thank you, ma'am.
Thank you, Varnika.
Thank you so much. And can I leave then? Thank you.
Yes,
Sorry.
yes, ma'am.
Sorry.
Yeah, please, you
I
can
had
leave.
a 2 o'clock meeting, so.
Thank you.
Okay, thank you.
Is Dr. Zubeda there?
Dr. Zubeda is also here. Zubeda ma'am, thank you.
Thank you.
Okay. IT expert, we can close this session. It's all done from our end.
Okay, sir. Okay.
Okay, thank
Thank
you.
you.